Hello everyone. I, Mrs. Vineeta Philip, Assistant Professor in Department of E&Tc Engineering of AISSMS Institute of Information Technology Pune, welcome you all for my series of videos pertaining to important topics of the subject Signals and System for SE E&Tc Engineering 2019 pattern. In this video, I would be discussing the fundamental signals along with its mathematical expressions and programming, which is the first practical of Signals and Control Lab according to SPPU 2019 pattern syllabus. So, what are fundamental signals? These are basically test signals used to check the performance of the system. These signals play an important role in the analysis of the communication and digital signal processing. Some of the different types of fundamental signals are as seen. To begin with, the very first signal, unit impulse signal, is denoted by del of t in continuous time. It is also referred to as delta function. The fundamental definition of the delta function is that the integration of delta function over time is unity. As t reaches to 0, del of t reaches to 1 and delta function is said to be unit impulse. In other words, unit impulse in CT is defined as signal of value unity at t equal to 0 and 0 for all other values of t. The unit impulse signal in dt domain is denoted as del of n, and the plot of the signals in CT and dt domains are as seen. Let us now see a program to generate and plot impulse signal. So for t from -5 to 5, as per the definition of delta, we know that it exists only at t equal to 0. The subplot function allows to have multiple plots on the grid within a single figure. The subplot command takes three input, n rows, n column and linear index. So here in this program we have 2 rows, 1 column and the CT impulse signal will be plotted on the first position. And the DT impulse would be plotted in the second position. X label and Y label are the command used to label X and Y axis respectively. Plot command provides the graphical plot. Stem command is used to represent data in discrete form. Title is used to name the figure. So as we know, only at t equal to 0, delta function has value 1. Upon hitting the run command, the figure window is generated and is as seen. The next signal that would be discussed in this video is the unit step signal. This signal is used in signals and system analysis because it can mathematically represent a very common action in real physical system. For example, in on-off switching circuit, switch is on or off. It has two states which can be easily represented by unit step signal. It is denoted by u of t in CT and u of n in DT domains. And the mathematical expression and the plot in the corresponding CT and DT domains are as seen. Now let us see how to generate the unit step signal. For a time interval say from -1 to 1 with a step of 0.01, there is directly a command in MATLAB as seen in the second line to plot the unit step signal. The viewers are requested to run the program and note the corresponding plot of the signal. The next signal is a ramp signal. It is denoted by R of t in CT domain and R of n in DT domain. A by t is the slope of the signal. If the slope is 1, then it becomes a unit ramp signal. The plot of the signal in CT and DT domain is as seen. The program to generate and plot the ramp signal is as shown. Here a new command is seen, which is the access type command, which sets the access limits to the range of data. The corresponding figure windows of the CT and DT RAM signal is as shown. The most useful signal in signal processing and communication theory is a sinc function. Mathematically, it is expressed as shown and the plot is as seen. Let us now see to generate and plot the sinc signal. For t up to 100, we will plot the sinc y as given in the second line. Then use subplot command. This signal is plotted for t versus the absolute value of y. We can plot both the amplitude and the phase plot separately, or as in this program, we will title the resultant figure as continuous sinc function. And in the same way, plot the discrete version of the sinc signal. The corresponding plots are as shown. The last signal discussed in the video is the rectangular signal. It is a common type of signal occurring in systems when the signal is switched on at some time and back off at a later time. Its mathematical expression and plot are as seen. Say for a given t from -20 to +20 with a step of 0.01, the rectangular pulse is plotted using the command in line number 2. The viewers are encouraged to run the program and observe the corresponding plot of the rectangular signal. That's all for now. In the subsequent videos, I would be explaining exponential signal types along with its practical demonstration. Till then, stay tuned. Thank you for watching.